Hi, this is Kevin, and I'm here with the tutorial for exercise 3 in the Zelle chapter 2 coding assignment. And in this one, we're going to create a classic conversion program. Uh, Here's what we're going to do. We're going to get a measurement from the user in kilometers. Okay, and then we're going to convert it to miles, and we're going to print it. We're going to print the measurement in miles. Okay, so this is a classic um, conversion program, and I'm going to talk about the design in a couple of minutes. And when I do, you're going to see that this really fits all parts of this input, process, output pattern. Okay, so let's get started on this one. I'm going to get a new Python file, and I'm going to call it kilometers to miles. Okay, enter. Okay, and you remember that we're going to need a doc string. So three double quotes up here, and then it puts in the last three. And I'm just going to say convert a measurement in kilometers to a measurement in miles. Kilometers to a measurement in miles. Period. Okay. Well, that's pretty. Okay. And that's using the the version that we uh, that's using the doc string that we learned about here when we're working in chapter 2. Okay, we're going to need a main, right? Let's put pass in there just to hold the place. And then we're going to need a call to main and a blank empty line behind it. And we got too many blank lines before that call to main, but there we are. That looks good. Okay. Let's look. So here's a chance where you can pause and not see my pseudocode yet, and then maybe you can jot yours down, right? And then you could play again and see how that goes. Okay, so here's my design for this one. And this one really fits this input process output pattern exactly because it's got code, it's got logic to put into all three parts. Input, prompt for measurement in kilometers. Okay, process, convert kilometers to miles. Output, print measurement in miles. Okay, so that's pretty straightforward. It really fits input, process, output. So that's very gratifying. All right, so let's, um, again, if you want to pause here and try to bang out the code before you see mine, well, please do. Okay. If you're not ready for that, well, maybe next week. Okay. So here's the first thing I'm going to do for code. This is the input part. Okay. So I'm going to keep the number in the variable kilometers. We're going to use input to prompt for please enter measurement in kilometers. And notice that we have the colon and a space there, so the user won't be jammed up against the colon when they're typing. Okay, and then we have all that wrapped in an eval to turn it into a number. We're still using eval here in chapter 2. When we get to chapter 3, we're going to give up on eval because it's very powerful and it's very convenient, but it's also very hackable. But we're not worried about that yet. Okay, well, that's good. Again, I just want to say, whenever you put in code, if you want to test it, like we can run this, and it's going to prompt, and let's say 300 miles, and enter. And it doesn't really do anything with it, but it behaves just like we thought. Okay, so what's the next part of our pseudocode? Convert kilometers to miles. Okay, let's do that. Now, um, I'm gonna bring this over like this. So I've got this, and I just need to bring over my conversion factor. Now, how did I find my conversion factor? Well, I found my conversion factor with a web search. Okay, for the programs that you folks are going to be doing, I put the conversion factors into the instructions for the exercise, so you're not going to have to hunt for them. Okay, and those are the ones that I want you to use. So miles equals kilometers times this 0.62137. That's the conversion factors of uh, kilometers to miles. Okay. And again, we could test that, but we wouldn't see any output. But let's do this thing where we print the output. Okay, and again, printing the output was what was left of the pseudocode. So the pseudocode's pretty simple, and you know this is a basic pattern, but you know it's always good to illustrate the thinking and the method because that's going to help you when the problems are even harder. Okay, so let's bring the output part over here. So let's copy one more thing and paste this. And so we're printing measurement in miles, comma, miles. Okay, and we're going to get a space between that colon and the miles because that comes when we're using the print and we're separating items by commas. Okay, well this should work pretty well. Let's run this kilometers to miles. So enter measurement in kilometers. Let's just put in a 1. Okay, and then it's going to give us back the conversion factor 0.62137. That looks right. Okay. And we could run it again. Let's do some testing. Let's give it let's put in 10.0. We can give it a float value. Okay. Well, we have a repeating fraction here, but we're not worried about these yet. We're going to learn soon in another couple of chapters. We're going to learn how to control how these floating point variables appear, and we'll be able to make them prettier than they seem to be here. Okay, so we've given it 1, we've given it a 10. What if we gave it a 0? So when you're testing, start thinking of, start thinking about the user experience here. Should the user, should the program, get interrupted and blow up simply because it got a 0 value? I don't think it should. Let's see what it does. If we give it a 0, no, it behaves pretty rationally. The measurement in miles is a 0. What about if we give it a negative value? What if we say the measurement in kilometers is a negative 10? Okay, well, it gives us the same number it gave us before, just a negative, and that's pretty rational too. Maybe we're thinking about what if we drive our car 10 kilometers backward? Okay, how many miles backward would that be? Okay, so we've given it, we've given it some good values. So when you're testing, don't just test a single value. I mean, test a range of values so that we can be confident that the user is going to have a good experience here. Now, there is, at this point, let's run this again. What if the user doesn't type in any number at all? What if we ask for a measurement in kilometers and the user types in "Hi Mom"? Well, it's going to blow up. Oh, okay. We're eventually going to learn how to um, catch that and recover from it if we want to. We'll learn about that in the end of chapter 7. So we've got a ways to go. But in the meantime, we're just going to trust the user to cooperate with our instructions. We don't have all the tools that we need to save them from themselves. Okay. So this is a pretty good looking program. Let's run this again. Let's just say 10 kilometers. We've got that. Are we done? Well, there's one more good practice that we haven't done yet that isn't covered in the Zelle book. It isn't covered in the lecture, but it's an important one. And that is most good programming books, teachers, soothsayers, they say that code in which you have a magic number, here we've got 0.62137. Okay. You can kind of see with this that it's probably the miles to kilometers conversion factor. Okay. You can almost kind of get away with that. So how could we document that better? Well, most people think that we ought to be using a name instead of a number. Okay. And there's a lot of things that we could do. I'm going to show you a couple, and we're going to settle on one. We're going to settle on the last one, actually, to tell you the truth. Okay, so what if we did this? What if we created a variable called kilometers to miles conversion factor? Okay, and we gave it the value of what until now is what people who just don't want to see the naked values in there, they call them magic numbers. And one of my colleagues, Elizabeth Wicks, she's not fond of magic numbers at all. And I remember her showing me that her version of the program had no magic numbers. So how would we do this? Well, we just would get a variable name here, and then we would use the variable name. Okay, so we're executing a little more code. All right. And of course, whenever we change the code, even if we don't think it's going to change it, we need to run it again. So again, if we give 1 there, we're going to get the conversion factor back. That's good. Now, is that the best practice right there? Well, I'm going to say that that's not what people do in Python. People in Python have another way to deal with this. And this is kind of a general approach in programming languages. If you've got some value that's going to potentially be used in more than one place in your program, in our case it's not going to be, but you don't want it to be a magic value, okay? We have this kind of concept in programming languages that we say that kind of a corollary to a variable is this idea of a constant. Okay, so it's like a variable, but you can't change the value. It just gets one value, and that value stays that way. It's a reference. Okay, now Does Python have constants? Well, Python doesn't have a mechanical thing that works like a variable that you can only assign it one value and then it can't take on any further changes of value. Okay, we don't have that. But we do have a convention where if we, as the programmer, want to signal to the reader that we don't intend to change the value of a variable, then we give it a special naming convention, which is that we name it in all caps. So we can just use this. Let's do, I don't know if we've done a refactor rename yet, but if we haven't, we'll do it now. So we're just going to take this variable, okay, and we're going to highlight that name, and let's right click and let's pick refactor rename, okay, and let's type over it here and put it into all caps. Okay. Underscores, kilometers to miles, conversion factor. Okay, so it changed it to uppercase. Okay. All right. Well, this code's going to work. Let's test it. It has a problem, but we'll test it here. Okay. So we give it 1, and it gives us conversion factor rate. That's good. Okay, so there's a squiggly underline here. Let's look. Well, you know what? Variable and function should be lowercase. That's what it was before. Oh, okay. So it turns out that inside of a function, it doesn't want you to define a constant. Why is that? Well, to the extent that you're going to have constant values, it wants you to put it in a place where it can be seen all over the program. Okay? And we don't put a lot of code out there, but here's what they want us to do. They want us to take this code here, this line, and we're going to cut it. Let's cut it. Okay. And let's paste it inside the program, but before we have the def for me. Okay, and let's give one more blank line here. Okay, and let's get rid of one blank line here. Okay, so it turns out that there's a couple of reasons why you might want to use a constant. And one is that maybe it gets referred to in several functions in your program. Okay, and if it's a reference, a value that's pretty important, yeah, it could be in more than one part of your program. And so they put it up here. If you do this, this name can be seen inside of functions. Okay. Now we in our class, and with the good practices that we follow, we put very little code out here in the clear, not inside of a function. Before this, we just had the call to main. Now we've learned if you're going to declare a constant, okay, which again is a variable whose value is not going to be changed, that Python programmers put these up here before main, outside of any function. This level, this top level of the program is sometimes called global. So this becomes a global constant. Okay. We don't, in our class, we don't consider it good practice to put very much up at this kind of top level, global level, but we will accept a constant there. So, what's kind of interesting, if you really want to do things the Python way, here we've got a pretty simple conversion program, and now we've had to learn about constants and where to place the definition of them in order to follow the good practice that we're not going to have any magic numbers in our code. Okay, and magic numbers, it could be magic values of any kind of thing. Uh, this is a good treatment, right? So when you read the code, it's very straightforward. You don't have to wonder, I wonder what that 0.62 blah blah is. We've named it, we've made it a constant, we put it up here. Okay? So this is pretty straightforward. Again, one of the reasons that we're doing it is to see just how powerful this pattern is. This is input, process, output. But to give us a little practice at putting together some pseudocode, and then to learn some of the finer points of Python coding, things like no magic numbers, and then how do you solve that? Well, you can't solve that without understanding about these constants that we defined up here in this global area, which we've been pretty timid about up until now, and we're going to continue to be timid about putting code up there. Okay, so that's it. Um, your program is going to be similar but not the same. So good luck on that, and I'll say bye until next time. Bye bye.